I hope you tried these. Not I will judge you from afar. That's what people wrote on the pages. Happy? Happy? Very good. Very neat. Like it. Colorful. Not very joy in my heart. You, even though you moved, you did right on it. Very good. Very happy. Colorful too. Like yours. Okay. This one says natural numbers. What are the natural numbers? 1, 2, 3, when you naturally count, right? Tomorrow we're going to start off where we have like daily quizzes and stuff, but today we're just finishing this lesson. It was in the course. I explained this. Why are you giving me this look like it's just so sad that I'm going to give the daily quizzes are not for marks. We just hand them out. It's like a little review thing. You try them on your own, and you discuss with others around you, or we go to boards. It's a low stress situation. Does it feel better now? Yeah. Okay. You look very stressed. Or just disappointed in me is actually what you look like. Okay. Natural numbers less than 20. Where do we stop at? 19. That are divisible by 3. So what's the first one?
3.
Yep. I need a pen. 3 then? Yep. 9. Yep. Mm-hmm. Yep. You did so well, and then you stopped. There we go. We had a sub in. New person came on board. Okay. Divisible by 5. What's our first one? 5 then? 10 then? Voila. Okay. So it's up above here it says, explain why the set of natural numbers less than 20 is a suitable universal set. Why is it suitable? Anyone know? They all wrote stuff. I saw things written. You're right. It's because both sets were limited to that. Good answer. Good job. No one answered. Just left me hanging here. Because both of them say natural numbers less than 20, natural numbers less than 20. So they're limiting both sets to be natural numbers less than 20, right? We can't use any other numbers outside of that. Correct? So that's why the universal set is a suitable universal set, because both sets, I shouldn't start with because, but I am because I'm a rebel. Both sets So if we wanted to explain the universal set, we could use that U that looks like a horseshoe. Remember, we have to put the top things on top of it because the U without that means union, which is something totally different you haven't learned yet. So we could list all of the elements. When you're listing the elements, you say the set of, that's what the two squiggle brackets mean, the set of numbers. And the numbers that are in that set, the set of the universal set, are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 19. Okay. Now the universal set we have to have if we are going to state the complement of something, right? If we're going to say what's not in something, we need to know our limited set of numbers that we can even use. And then as long as we have one set, we can always say what the complement is, because it's just no, it's not in that set, correct? So this one here means a complement. So it's basically what's not in A, but in the universal set, correct? So A has 3, 6, 9, 12, 15, and 18. Universal set has all those numbers. Not A is everything that's not in A. So it would be 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. So here it says write a description of elements of the complement of set B. So if B is, in words is the natural numbers less than 20 that are divisible by 5, what would the complement be? Natural numbers less than 20 that are not divisible by 5. That's it. Yep. Complement to B. Set C are the natural numbers less than 20 that are multiples of 6. So we can state all the ones that are multiples of 6. So C would equal 6, 12, and 18. And then we have to state if the subset things are true, right? Now remember, the first letter is a subset of the second letter. If that's a true case, then everything in that first letter has to be contained in the second one, right? The second can have more, but it has to at minimum have what's in the first letter, right? So if we're looking at C, we're saying if they're true or false. C is a subset of A. That means everything in C has to be found in A. We agree? So C has 6, 12, and 18. So in order for this to be true, A also has to have 6, 12, and 18. Does it? 6, 12, 18. Yes, it has more, but that doesn't matter as long as it has the 6, 12, and 18. So this is true. And this one says C is not a subset of B. So the way to test this is to see if everything in C is in B. The moment one thing in C is not in B, it's not a subset anymore, right? It only has to take one thing to make it not a subset. So C has 6, B has 6. Does it? So C is not a subset of B. That is a true statement. And then here it says not A is a subset of not C. When I want to compare them, I will always write out the sets that are being compared. So I have not A already, the complement of A up there. The complement of A is already stated, right? But I don't have the complement of C, so I like writing them both out so I can compare them. So the complement of C is everything but 6, 12, and 18. So it would be 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, and 19. Now, in order for this to be true, complement of A has to be all B and C. So let's check it out. Complement of A has 1. The complement of C has 1. A has 2, 2, 4, 4, 5, 5, 7, 7, 8, 8, 10, 10, 11, 11, 13, 13, 14, 14, 16, 16, 17, 17, 19, 19. So is it true? Is everything in not A, complement of A in not C? Complement of C? Yes, it's true. So we're using the previous sets that were defined earlier. We're using even or E as 0, 2, 4, 6, 8, L is 0, 1, 2, 3, 4, 5, 6, and O is 1, 3, 5. We've talked about subsets. If something is a subset, that means everything in the first set is found in the second set, right? That's the biggest definition we have. But then we're also going to move into intersection and union. Oops. I don't even know what just happened. Okay. So the intersection of a set, if you look over here on your formula sheet, intersection is this little symbol here. It's like an upside down U. So it looks like this. That's the intersection. The intersection of a set A and set B is called A and B and is denoted as that symbol. So if it asks you for the intersection of A and B, it'll look like this, A intersection B, okay? Now, how I remember what the heck intersection stands for is I go like this with my symbol, and if I can write that into the word and, it means and. So intersection is and union is going to be or, okay? So this means and. So it's what's in A and in B. You're going to only list the elements that are in A and B. So it has to be in both. If the elements aren't in both, I don't list them. That's basically all it is. Okay? So here it says, it is the set of elements that are members of both sets A and B. Write the intersection of E and L using appropriate terminology. So if we want the intersection of E and L, we're going to go the intersection of E and L. And then we have to list the elements that are in the intersection of E and L. So what is in common between E and L? 0. What else? 2. 4. 6. That's it. So if I ask you the intersection of a set, you literally just give me the numbers that's in both. That's it. That's all I'm asking for. Nothing harder than that. The union of sets looks like this. And it's or. And how do I know it's or? Because if I try and write it as the word and, it looks stupid. So therefore, it's or. Because one of them is or and one of them is and, just so you know. And the symbol that can write the word and is and the symbol that cannot write the word and is or. That's it. That's how I remember it. Now, or should often have more, and I'm going to write that here. Or should have more. So if I was talking about a two grade 6 classes, let's circle back to that. I was talking about 2 grade 6 classes, and I wanted to know how many kids were in this class and the other class. How many would you tell me are in the 1 grade 6 class and the other grade 6 class? It's a trick question. The answer would be 0. None of them. None of them are in grade 1 grade 6 class and the other grade 6 class, right? Grade 6 classes are totally different. You don't overlap. It's not like up here, right? So they would be empty. It would be an empty set, actually, between the 1 grade 6 class and the other grade 6 class. There's no overlap. But if I said to you, who's in this grade 6 class or this grade 6 class, who would you list? In this grade 6 class or this grade 6 class? You would list everyone. Because anyone in this class or in this class will get listed. We agree? So or gets you more. If it's in one set or it's in the other set, I'm listing it. If it's in both sets, I'm still listing it. I just don't have to list it twice, right? You can list it once because you've covered it already. Okay? So and has to be in both before you can list it. Or if it's in one or it's in the other, I list it. If it's in both, I still list it. Okay? So when I'm asking you who's in this grade 6 class or this grade 6 class, you'd list every kid's name that's in either of the classes. But and would be none because there's none that overlap. Okay? So the union of set A and set B is a set called A or B, and is denoted as A union B. It is a set of elements that are members of either set A or B. You're inclusive. You're including every single person who's possibly in either one. Okay? Use appropriate notation to write the union of set E or L. So if it's in E or it's in L, I list it. If it's in both, I list it, but I just list it once. Okay? So I like listing it in order. If you listed it not in order, it would still work. Okay? You just might miss some, so I like listing them in order. So 0 is in E, and it's in both, so I list it once. 1's in L, so I list it. 2 is in both, so I still list it. 3 is in L, I list it. 4 is in both, I list it. 5 is in L, 6 is in both. So if the number appears in either or, you list it. So or often results in it. Yeah?
And 8.
Oh, and 8. Good call. Oops. Yes, we need 8 too. The other definition we do is disjoint sets. So 2 sets are said to be disjoint if they have no elements in common. So for example, those 2 grade 6 classes would be disjoint because they have nothing in common. This grade 6 class and this grade 6 class have none of the same kids, right? They're totally separate classes. So those 2 sets of classes would be disjoint. And how can you tell disjoint? Well, if I went A and B, if I asked you for the intersection between A and B, so I'm asking you which elements are in A and in B, you'd tell me none. You'd tell me the empty set. That should be a 0 with a line through it. It's just not really through the middle, like that. So A and B would be empty. And if A and B had nothing in common, they would be disjoint. So these 2 elements here, this set is 2, 3, 4. This set is 5, 6, 7. They're disjoint because they have nothing in common. No number overlaps. Okay? And you can prove disjoint by proving the intersection results in an empty set. If the intersection results in an empty set, the 2 sets are disjoint. So here it says which of the 2 sets from set E, L, and O are disjoint. Well, I'm going to list them again. So E, hold on, this paper's down. So E is You have it on your page, so you don't have to, but my board's too small. L is Are there any two sets here that have not one element in common, Sam? E and O. E and O have not one set in common, or not one element in common. I have 0, nope. I have 1, nope. I have 2, nope. I have 3, nope. 4, nope. 5, nope. 6, nope. 8, nope. Nothing in common. So I can show it by going E, the intersection of E and O, results in the empty set. It's an equal sign, even though it doesn't look like it. Equals the empty set. And since that happens, E and O are disjoint. Right? So the definitions we looked at here are intersection, what's in both, this set and that set. Union is or. If it's in one or the other, I list it, so it's often a bigger set of numbers. And disjoint means nothing in common. If you take the intersection of them, you get the empty set. So we're going to look at example 3. So example 3 here says, consider the sets A, B, C from class example 2. You are the natural numbers less than 20. So here we have divisible by 3, so 3, 6, 9, 12, 15, 18. Divisible by 5, 5, 10, 15. And C is multiple to 6, 6, 12, 18. We used these before, right? We just finished with these ones. So here it wants us to list the elements of the following sets and describe each set in words. So let's describe it first. This would be set A. And what does this symbol mean? Intersection. And remember, if we forget, the formula sheet has it. Like, it literally tells us. So it's set A, intersection, set B. And what does this symbol mean? Remember, if I can do this and write the word and with it, it means and, correct? So I know this one means and. And means it needs to be an A and B. So what's in A and B? Is there anything in A and B? 15. That's it. Then this one is set A union set B. Bless you. And I know they either mean or and if I try and write the word and with this, it looks stupid, correct? So this one means or. Bless you. So if it's in either A, ooh, I just died there. If it's in either A or in B, we list it, correct? A or B. So what's in A or B? Lots of stuff, right? What do you got? 3. What else? 5, 6. And then not A and B. So this would be the complement of A. Intersection B. And I will always list the complement out before I try and do the intersection of it. I literally will. I know it takes a bit more, but I don't care. So A complement is all the natural numbers less than 20 that are not 3, 6, 9, 12, 15, or 18. So it's going to be 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Now remember this symbol, you can write the word and, correct? So I need what's in the complement of A and B. So are there any numbers in B that are in the complement of A? 5 and 10 only, yeah. And that's where we're going to stop. We're going to finish up B, do the homework part of it tomorrow, and then we're going to move on to Venn diagrams as well. But we're going to do some review at the beginning of class as well. Okay? So the rest of the class, you can finish up your homework because we're going to check it at the beginning if you haven't finished it yet.